Okay, I hope this is recording. Everything's all messed up today. All right, so we're solving logarithmic equations today. So it's a little bit like yesterday, a little bit of new stuff, not super difficult. All right, so let's look at our first example. Log base 32 of x equals 3 halves. So we can rewrite this exponential form. This is going to be 36 to the 3 halves power equals equals x. Thank you for changing colors right in the middle. Okay, so really this isn't that difficult. This is just an exponent. You can put this into put it into a calculator. You might need to put some parentheses around the 3 halves to make sure raises that power. Another way you can think of this, remember we talked about yesterday that if you have a fractional exponent, that the number on the top represents the power and the number on the bottom is the root. This is not a good error. So 36 to the 3 halves power is equivalent to 36 cubed and then the square root of that. But you could also put it to a calculator, okay? But then there's something neat you can do. Let's say this shows up on the SAT someday, and it's the non-calculator part. If you notice, we have 36 as our base, and 36 is a perfect square. So what we could do is we could say 36 is actually 6 squared raised to the 3 halves power, right? So then we multiply this together. 2 over 1 times 3 over 2 is 6 over 2, or just 3. So this becomes just 6 to the 3rd power equals x. And 6 to the 3rd power, we can actually solve, right? 6 times 6 is 36. 36 times 6 more is 216. So most of the questions you see today that are in this form will have this similar kind of trick where you can rewrite the base and that'll cancel out the fractional exponent. So you end up with something that you can solve without necessarily needing a calculator. Okay? But you definitely can put this into a calculator and you'll still get 216. Okay? All right. Our second example, this is just what we did yesterday. Log base 8 of 1/2 equals x. So we can rewrite this as an exponent. This is 8 to the x power equals 1/2. So I know since I have a whole number on one side, fraction on the other, my answer is going to be a negative. This is actually, it's probably going to be -3, right? But let's go through the steps just in case. So 1/2 is 2 to the negative 1st power equals 8 over x, right? No, maybe? Let's find out. I don't know. Let's see what we get. So 8 is 2 to the 3rd power raised to the x equals 2 to the negative 1st. So then this becomes 2 to the 3x equals 2 to the negative 1st. And then once we have the same base, we can say that 3x must equal -1. Or if we divide both sides by 3, we get x equals -1/3. That's right, I forgot the whole thing. Since it's going from 8 to 2, it's getting smaller, and anytime it gets smaller, you have a fractional answer, or fractional exponent. And then since we had to flip one of these over, that's why it's negative. Good thing I worked it out. I would have gotten the wrong answer. Okay, so the last one, this one that's really new, and this one's the one that kind of looks scary. So log base 2 of x squared minus 4 equals log base 2 of 3x. So don't let this freak you out. This isn't actually any new math we have to do here. So if you have 2 logarithms of the same base, right? If they both have the same base, then the number after it, right? In order for these to be equal, this part that we underline in blue, those have to be equal. So therefore, we know x squared minus 4 must equal 3x. And now we're just solving for x. So we have x squared. So you're like, quadratics. I've done those before. So it's going to be x squared minus 3x minus 4 equals 0. Okay, hold on. And back. Okay, so x squared minus 3x minus 4 equals 0. So any way you want to solve this, you can. I'm going to stick with factoring because we just have x squared, so we can probably factor this. So what two numbers multiply to -4 and add to -3? And that is -4 and +1. Okay. And that still equals 0. So what are our values of x have to be? Remember, it's just the opposite at this point. So if we have x minus 4, x plus 1, then x must equal +4, or x must equal -1. Okay? So here's the part that's a little bit different. We have these two solutions, but we need to see which of these will actually work. So when we deal with logarithms, this number at the end, so if we say log 2 of just x, this x value, it cannot be negative, it cannot be 0. So it has to be a positive value. Okay? So I need to check my answers, and I need to be able to put them into either of these that are underlined in blue and come up with a positive result. Otherwise, that answer cannot exist, and we throw that one out. So I can put in either x squared minus 4 or 3x. 3x is a little bit easier, right? So if I say 3 times 4, that's 12. So that's good, right? It comes out to a positive. That's a valid answer. But if I say 3 times -1, I get -3, and that cannot work. So this x equals -1, this is a extraneous solution, so we don't need it. Okay? That's not always going to be true. Sometimes you will have 2 valid solutions, but we just need to make sure that we double check. Okay? For the ones today, I think there's at least one where you get 2 solutions that work, but they don't both show up as an answer choice. So just pick the answer choice that has one of the correct solutions. Okay, so try these out. Remember, if you have log base of x, you're just solving an exponent. If you have log base of a number equals x, then you're going to set it to the base 2x equals a number, and then you solve for that exponent. Or if you get one of these, you take everything after the log, set those 2 sides equal to each other, and then solve for x. All right, so good luck. Let me know if you have some questions. All right, bye.